climate change in Vanuatu. And so for the first part of this talk, I just want to cover what we know about tropical cyclones and climate change from scientific papers and things like the IPCC up until now. And then the second part, I want to focus on the portal and discuss some ideas for things we can show in the portal, and hopefully get some feedback from everybody on what would be useful to convey in terms of tropical cyclone activity. So just briefly, the hazards of tropical cyclones. Most people probably think about wind as the main hazard, and this is certainly what insurance and other industries try to understand, because it can obviously do a lot of damage. But of course, there's also heavy rainfall, which can lead to flooding. And as it turns out, the rain is actually the thing that we expect to increase the most with global warming. We'll talk about that a bit later. And then, of course, there's storm surge and also damaging waves and occasionally tornadoes as well that develop during tropical cyclones when they make landfall. So for this work, for Van Curup, we are just going to focus on the wind component and the rainfall component. So not the storm surge or the waves. So firstly, I just want to give a brief overview of recent trends sort of over the last 30 or 40 years in things like tropical cyclone frequency, intensity, the intensification, and also the rainfall. So in terms of the global number, this is the global number of tropical cyclones from 1970 to about 2020, so about the last 50 years. And you can see that globally, there's been pretty much no trend. So the annual number is about 85 tropical cyclones per year. And this number has been very steady over the last 50 years or so. And if we look regionally, we actually see large variability in terms of the trends. So this map shows the trend in tropical cyclone frequency from 1980 to 2018 from a study by Murakami in 2020. And what you can see is that for the South Pacific, particularly the Coral Sea, including Noumea and Vanuatu, there's been a downward trend in the number of tropical cyclones. You see the same thing for the Western North Pacific. And the Atlantic really stands out as being one of the only basins that has a significant upward trend in the number of cyclones in the last 30 or 40 years. But the interesting thing is that despite the differences in the trends in each region, the net result is basically no trend. So the differing trends sort of cancel each other out if you look at the global trend since about 1980. In terms of intensity, tropical cyclone intensity trends, there was a study recently by Cosson et al. 2020 who looked at the fraction of times that tropical cyclones spend at a major intensity, or in other words, winds greater than 128 kilometers per hour, or US category 3 and above. And what they found is that the fraction of time that these cyclones are spending at higher intensities is increasing. And it's been increasing both globally, which you can see on the left plot, as well as in different basins. So for our region, you can see there's been a large increase in the Southern Indian Ocean, as well as in the South Pacific Ocean. So we have some understanding of the physics behind why tropical cyclone intensity is increasing, and it's related to something called the potential intensity. And I won't get into details of the exact way that we measure the potential intensity, but you can think of it as something like the sea surface temperature. And so from 1970 to 2018, this potential intensity, which is a kind of an upper limit for the intensity of tropical cyclones, that's been increasing pretty much everywhere where we experience tropical cyclones, including in the South Pacific and the Vanuatu region. And we expect this to continue to increase as well with global warming. So we have some expectation that because of this, that tropical cyclone intensity will respond and will continue to increase as well. So closely related to the intensity is what we call the rapid intensification, as many of my colleagues at VMGD would know about. And this is officially defined as an intensity increase of at least 30 knots in 24 hours. And what makes these rapidly intensifying cyclones dangerous is that some of the models don't really capture the intensification rate, especially the very rapidly intensifying cyclones. And there's been recent studies that have shown that this, I should say the proportion of these rapidly intensifying cyclones compared to the total cases, the total number of cyclones, so the fraction of rapidly intensifying cyclones is increasing. And this is just for the North Atlantic basin. And you can see there's an upward trend from about 1980, but we're starting to see evidence in other basins, including the Southern Hemisphere, that these rapidly intensifying cyclones are becoming more common. And this is also something that we expect to continue to increase with climate change. So finally, in terms of recent trends, tropical cyclone rainfall has been very topical, partly because of major events like, for instance, Hurricane Harvey, which hit Houston in 2017 and caused over 1,000 millimeters of rain for Houston, which was like a record at the time. And there's been a lot of anecdotal studies and evidence suggesting that these types of events are becoming more common as we move into the future. However, one of the recent review papers basically found that there's been yet no observational studies, at least at the moment, that have provided evidence of a detectable anthropogenic, so human influence on tropical cyclone rainfall. Although this is, as I said, and I'll show you in a second, this is actually the variable that we expect to increase the most. It's just that maybe because of the observational network or other reasons, we haven't yet been able to detect a very strong trend in the rainfall. So this is just a summary slide of what I just showed. The only thing I didn't talk about was this poleward shift in the latitude of the maximum intensity, which I left out for time, but there is some interesting work on that. If people are interested, then please let me know and I can send you the information on that. Okay, so those were the past trends. So now I just want to focus briefly on what's next. So what do we expect in terms of future climate change, and also talk about some things that we can integrate into the portal that staff and others will talk about later today. So this is an overview figure that was developed about a year or two ago in a review paper by Knudsen et al. 2020 from GFDL. And it shows the changes in tropical cyclone quantities for different regions of the world, as well as the global change. And this is for a 2-degree warming scenario under a high emissions RCP 8.5 from the CMIP5 models. And my understanding is that we expect to reach this 2-degree warming in about 2050 or something like that. So when we look at these percent changes, we can think of these as sort of valid for around roughly 2050. So for the Southwest Pacific, which I've highlighted here in red, what we can see is that the thing that is most, that we expect to increase the most is the rain rate. And so in this case, we can see it's about roughly sort of an 8 to 10% increase in the mean for the Southwest Pacific, with large variability. The intensity, the maximum intensity, we expect to increase, in this case, maybe by a few percent. But again, there's very large variability. Some models show a decrease in the intensity, but the majority of the models show an increase in the intensity. The tropical cyclone frequency, we expect to decrease. You can see most of the models surveyed here have a decrease, and the mean is about 15 or so percent. And the number of category 4 and 5 cyclones shows large variability, but is also expected to decrease in the absolute number. And that's because overall, we expect the total number of cyclones to decrease. So the number of category 4 and 5 cyclones is kind of tied to this decrease in the total number. But what I should say is that the fraction or the proportion of category 4 cyclones for future climate is expected to increase. So it's important, I think, to differentiate between the fraction of category 4 and the absolute number of category 4, 5. So that was just a summary of expected changes out to about 2050. And now I want to talk briefly about the portal. So about a couple of months ago, also Dewi and I met to discuss various features that we could incorporate into the portal. And this is something that would be really great to get your feedback on, because there's lots of different ways to display the information, and we'd like to understand sort of what's the most useful format or ways of conveying things like the frequency change, the intensity change, and the rainfall. So before I continue, I should say that the data that we're using for the portal for the tropical cyclones is from the MIT synthetic track model. So synthetic tracks are essentially a way of simulating tropical cyclones in climate models that allows for the full distribution of intensity, which is helpful because most climate models are too coarse in resolution to simulate things like category 4 and category 5 tropical cyclones. And given that these are the cyclones that produce most of the damage, we need to figure out a way to simulate these high-end events. And so the synthetic track approach allows essentially the full spectrum of intensity. And so we can start to look at things like the changes in category 5 tropical cyclones for a given region. And so what I'm showing here on the right is the 50 most intense synthetic tropical cyclones that pass within 200 kilometers of Port Vila. And this is for the period from 1979 to 2019. So these are the simulated synthetic tropical cyclones. And the color scale shows you the intensity. So the red is are the most intense parts of the storm. So here is a list of things that metrics that we think would be useful to display in the portal as far as tropical cyclones go. So for both the historical period, which is in this case 1981 to 2000, and the future, which we have two periods, which I'll talk about later, is the middle of this century, around 2040 to 2060, and the end of the century, around 2080 to 2100. We can show different variables. So one is the tracks, the TC tracks from observations and from model data. The second is the gridded TC frequency. Thirdly, the gridded TC intensity. And then finally, some measure of the rainfall. So either the rain rate in millimeters per hour, or maybe the accumulated rainfall. So the total storm rainfall for a given location. I'll talk about those at the end. Okay, so as far as the cyclone tracks goes, we already have some existing portals that we can build upon, which some of you may be familiar with. So the first is from the Bureau of Meteorology's Southern Hemisphere Tropical Cyclone Portal. So I've put links to both these portals at the bottom of the figures, so you can click on the link and hopefully explore these more if you haven't already, and maybe get back to us with feedback on what might be important. So for the Bureau's portal, it allows you to select the years, the historical years. You can choose, say, 200 kilometers from Port Vila, and then it brings up a map of all the tropical cyclones that passed within 200 kilometers of a given location. On the right-hand side is a similar portal developed by NOAA, which allows you to do similar things. You can select a circle and look at events that passed within a particular circle from a location. And in addition to the track, it also has information on the intensity. So on the left-hand side, this is Tropical Cyclone Pam. You can see it has the wind and the pressure information for each point along the track. So we could potentially do things like this for the model data, the synthetic tracks, as well as for the historical data for Vanuatu for the portal. In terms of the frequency, we were thinking of gridded maps. So this shows you information on tropical cyclone frequency from the synthetic tracks using the, sorry, I said 1981 to 2000. So actually it's from 1986 to 2005 is the historical period. But basically, yeah, this shows you the number of cyclone tracks per grid box per decade from the synthetic tracks. So on the left-hand side, we have the historical, and then on the right-hand side, we have the future frequency from 2041 to 2060 and towards the end of the century, which is 2081 to 2100. And the bottom plots show you the differences. So as you can see, the synthetic track model indicates a decrease in frequency for the Vanuatu region, both in the mid-century and also towards the end of the century, with a greater reduction in the numbers per grid box at the end of the century. And this, I should say, is an average of 8 climate models using the 8.5 high emissions scenario, so the scenario that Dewi touched on in her talk earlier. So that's one option for showing the frequency changes for the Vanuatu region. And we did something similar for the Australian region in the NESP Tropical Cyclone Portal, which my colleague Tony Rafter developed along with other colleagues at CSIRO about a year or two ago. And so this shows you an example of the frequency change for the entire Southern Hemisphere using slightly different baseline period from 1970 to 2000 and also future period. But it gives you an indication of the type of thing that the portal could show. So yeah, so please feel free to click on the link and play around with the portal and let us know if there are any features in this portal that might be useful. So I've only got a few more slides left, but just briefly, as I said earlier, one of the very nice things about using the synthetic tracks to simulate tropical cyclones in future climate is that it can reproduce many aspects of intense tropical cyclones. So on the left-hand side is one random track that hit Vanuatu in January 2010 in the model climate. And you can see in this case, it approached from the northwest, moved over Santo, and it rapidly intensified from about the 25th to the 26th of January. And the blue curve on the right-hand side is the maximum winds. And so you can see that it captures this aspect of rapid intensification that we're concerned about with climate change. So that's great. So it allows us to assess things like the change in high-end Category 5 cyclones for the islands. So a question is then, how best do we display this information? So one option is to do a gridded map. And for this, this is just an example of something called the power dissipation index, which is essentially the maximum wind speed cubed, and it's proportional to the damage usually. But this could really be anything. This is just an example. So for instance, we could show the peak intensity as measured by the peak wind speed in a grid box. We could show the number of Category 4 and 5 cyclones per decade, or any other measure of intensity that might be useful for stakeholders. On the right-hand side is a slightly different option, which would be to select a location. So in this case, I've shown an example of selecting cyclones that pass within 150 kilometers of Port Vila for the historical climate. And what I'm plotting here is what we call the annual exceedance frequency. So this is the probability of a storm at a given intensity affecting the point of interest. So in this case, for example, 0.1 means that there's a 10% chance that if we look at where 0.1 corresponds to on the scale, it's about 100 knots. So what this is saying is that there's a 10% chance of a 100 knot peak intensity cyclone passing within Port Vila in the historical climate. And so we can do similar things for future climate and assess the probability of say, a Category 4 cyclone affecting this region, and assess the change in the probability. So, you know, will a Category 4 cyclone be more likely to affect Port Vila in future climate than it is in the current climate? Things like that. Finally, we were thinking about how best to show the rainfall. So on the left-hand side is a zoomed-in version of Santo, and this shows you the average simulated tropical cyclone total rainfall for the islands. And in this case, I don't know exactly how to verify this, but you can see that there's much higher rainfall totals on the slopes of the mountains, especially on the east side of the mountains. And so that's one option, is to show us sort of a gridded product of rainfall of tropical cyclones, and then we can look at how this changes in the future compared to the current climate. And then the second option is similar to what I showed for intensity, where you can select a given location and look at the probability of a particular extreme rainfall event occurring at that location. And so in this case, I've chosen an example of Pacoa Station, Pacoa Airport Station. And this shows you, for the historical climate, the return periods, so the probability of a given rainfall threshold being exceeded. This is total storm rainfall. And you can see basically it goes from about 100 millimeters out to about 1200 millimeters. And as an example, I've just shown what Tropical Cyclone Harold was. So my understanding from the spreadsheet that colleagues at VMGD provided was that Harold produced a lot of rain, up to 900 millimeters or so for the station over a few days. And in the current climate, this event would be about a 1 in 300 year rainfall event. However, just as an example, this is just an example, but let's say that the future climate, the rainfall looks like this for the station. Then what we can do is make some assessment of the change in the probability of something like the rainfall from TC Harold in a future climate. And in this case, it might go from a 1 in 300 year event to something like, you know, a 1 in 50 year event or something like that. So in other words, an increased probability of an extreme tropical cyclone Harold-like event for PCOA. So that's it. Thanks very much. And yeah, we welcome any feedback on, again, on how best to incorporate some of this information into the portal. And I have a thank you slide here also with my email if anyone wants to get in contact. Of course, you can also reach out to Davey and Jeff, and they can pass on information to me. So thank you. Questions? Comments?
Hamish, could I just prompt something? So for the NOAA website, where you're able to click on various points along the line of the synthesized tracks, I can see how that's really useful for historical cyclones. Yep. But for projected or synthesized ones, yep, I just wondered how would it almost be misleading if we put that in the portal, because it's such specific information for each of those points. I can see how the synthesized tracks are really awesome for generating the gridded data, but to look at it at in such a precise way, it's maybe not supposed to be viewed with such precision. What do people think? Would that be useful? Like if that cyclone is just kind of made up, is there any point in knowing exactly what it's going to be like at any point if it's just made up anyway? Does that make sense?
Yes. Oh, sorry, I'll jump in and then I'll let our VMGD friends weigh in as well. But I agree with you. I think for the historical information, this is a very useful way of looking at historical events. But I think for the synthetic tracks, it's probably more useful to show the statistics, the kind of aggregate statistics of the synthetic tracks in the portal rather than an individual event. As you said, the individual event might be slightly misleading, I think. So.
And by contrast, could you show like that gridded map of projected intensity in different areas looked really useful, which I suppose is derived from the synthesized tracks, hey?
Exactly, yeah. Yep. So that's right. So this is this is from the synthetic tracks in the historical climate, but we could do things similar to this map for the frequency, but for intensity. So we could show differences in intensity for each grid box from the, for the future climate minus the historical climate to see how the intensity might change. So things like that. Any other comments or feedback from anyone?
So, hi, Hamish. It's good to see you again. Thank you for a very wonderful, thank you for a very good presentation. Actually, I was thinking along the same lines as what was it Stafford was asking about. Yes, but yes, I understand that if that were possible, that maybe it might mislead, given that when we do projections, it's the longer the term is, then the uncertainty is greater.
Yeah.
What I am thinking about is earlier when Dewi was doing her presentation, he she divided the Vanuatu into 3 regions. So I was thinking probably it could be possible to have that sort of that sort of information provided on for each region, for the 3 regions, rather than like for a specific island. Say if I wanted to see a projection for the northern islands of Vanuatu, then maybe I could have an idea of how many maybe not the number of cyclones, but the rainfall or intensity of cyclones.
Yeah, that's a good point. So, okay, so what you're saying is rather than just Santo, to focus on a region, say the northern region and the southern region or something like that.
Yeah.
Okay, thank you. Yeah, that's really helpful.
I think I totally agree with the previous speakers in relation to how to present historical tropical cyclones through the example that you've given on, I think, your slide number 18.
Something like this.
Yeah. But I think the examples that you've given, looking at the NOAA example, where they're also presenting the atmospheric pressure and wind. I think that is something that we are very interested also to have in the TC track, that we can interrogate the tracks of historical cyclones, but also look at the intensity and what particular time that the maximum winds close to the center have occurred. So that's, I mean, I agree with Stanford's and Mora, but in terms of the presentation of future cyclones that you have derived from the gridded data, virtual cyclones that you've created, I think that those 2 examples using the gridded map, as well as the the curve, the return year. The
return period or the exceedance frequency?
These 2. I think these 2 will really be useful for our purposes in terms of presenting that projected cyclone intensity for Vanuatu. But with the small addition from Mora, maybe make it interactive so that the user or people who are interested in cyclone can then zoom into a particular region of Vanuatu or zoom in to an island with the example of Santo you provided. But I think we're very happy with the options that you presented. Thank you very much for that.
Thanks very much for the feedback. Okay, so what you're saying is it would still be useful, you think, to be able to select a given location on the map and bring up some information on the probability of different wind speeds or different rainfall thresholds, like this for Pacoa Station? That's correct.
That's correct. Because, you know, during tropical cyclone events, when the president of Vanuatu declares a disaster and the cyclone is passing through, the government will be asking Meteo, hey, what is this cyclone? How it does compare to previous cyclone? Is it the 1 in 50 event? Is it 1 in 300 event? So yeah. I think these are very good information that we can have in our back pocket. When we're preparing those briefing notes to our political leaders, we can say, this is similar to PAB, this is similar to Harold, you know, but using those sort of easy ways to communicate the intensity and the risk and impact of these events for, you know, general consumption, not in a technical way.
Okay, great. So yeah, so this is exactly what I was hoping to get from the return periods, was to say things like the tropical cyclone Pam in future climate is going to be, you know, a 1 in 20 year event or something like that. So you can start to make some sort of comparison between historical events and future events. So that would be useful.
Correct. That will be useful. And I think your earlier slide in relation to projections where you're saying that frequency of cyclones that are between category 3 and category 4 will be less frequent in the future.
Yes.
Looking at just a fraction of those storms, category 3 up to 5, it will be much more severe. But for us in Vanuatu, just one category 5 is enough to take us back to 10 years of our development. But I think it's still important information that we need to present to the people and our leaders for them to, put more money into disaster risk reduction, put more money into awareness, put more money into strengthening our collaboration across all the sectors economy-wide,